Welcome to Topics in Planting Design, Session 2. This is a technical knowledge session about comparing elements of plant lists for large or complex projects and seeing an easy and effective way to prepare a preliminary plant list. And then we'll take a look at sun and shade, its importance in planting design, and how to make a simple do-it-yourself graphic sun angle shadow length tool using suncalc.org and Bluebeam. Our assumptions for this session are: goal landscapes or landscape typologies are established, and the community landscape character is understood. So we generally know what kind of plants we want. There may already be a design plant list developed by others that you need to study and evaluate, and sometimes the design plant list is developed by someone. A carefully considered plant list is the starting point for realization of the landscape concept. Large and complex projects tend to have complex plant lists. This one from UC Merced is in the early stages of design. Plants were selected and placed into many different design categories. You can see here 3 each for some of the trees and grasses. The original list was developed by Hargraves and Associates. It included a high percentage of native and drought-tolerant plants. An overriding issue for the university was a strong requirement to use plants requiring little to no maintenance, and the original plant list was extensively modified to comply with this stipulation. Brightview revised the original Hargraves list in close consultation with university authorities. It gave us a chance to develop and implement several grassy meadow seed mixes, though not as many as conceived originally by Hargraves. We will continue to monitor their growth and succession to see how they perform over time. The plant list on this page is for the Gaylord Marriott in Chula Vista. The original list was formulated by KTUA in San Diego with Jeff Sugar of EDSA in Florida. The resort includes several distinct landscape types: an ornamental tropical landscape at its main entries and the extensive water park pool complex, a series of tropical, desert, and California-themed interior atrium gardens, as well as a perimeter native landscape with bioswales and slopes. The Coastal Commission, as a condition of approval, requires that the site uses 75% native plants, so these perimeter areas became important landscape zones. Plants were categorized by USDA and Sunset Climate Zone, California native status, plant status on previous plans because the project extends back many years, wool calls water use, height and width, sun and shade preference, and whether it is an endemic native, a local cultivar, also known as a locavar, or a hybrid. It turned out that the design concept for the native plant zone had a few issues. A species review revealed that many plants in the original native plant list were coastal salt marsh species, not often used in landscape design, and thus few of them are available on the commercial market. In addition, the pool area and the atrium plant lists were incomplete and needed to be developed. For this Bay Area corporate headquarters project, in the search for the most pure, locally endemic native planting design, this project's master designer, Thomas Heatherwick in London, worked with local biologists and agencies in the Bay Area to formulate several native California landscape design archetypes using 100% locally endemic natives, whereby certified Phytophthora-free contract grow will be required. The plant lists comprise several complex mixes, including grassy and shrubby meadows and woodlands, a security berm, functional bioswales, and interior native plant atriums. One of the challenging aspects of this project is finding and confirming plant species that will thrive on the shady north-facing 6 sides of a 6-story office building, also under its 3-story covered entry plaza, and within the 3rd-floor open garden atriums. Rancho Mission Viejo planned residential community has a very detailed series of plant lists categorized by plant types: trees, shrubs, grasses, succulents, ground covers, and vines, and also by functional plant location: foreground, middle ground, background, and accent. And furthermore, it's classified by architectural style. That is, which plants go best with certain architectural elevation styles, such as contemporary, farmhouse, prairie, progressive, Spanish, mercantile, and ranch. I have found that categorizing plants based on what architectural style goes best is usually not helpful. First of all, it's subjective. I mean, who is to say which plants do or do not belong with an architectural style? And second, along with all the other requirements in the matrix, one can quickly and easily run out of plants that meet all the necessary criteria. That seems to be what happened here. In the list above, nearly every plant checks all the boxes for every architectural style. One wonders why Dianella Little Rev doesn't go with mercantile architecture. The Great Park Neighborhoods planned community has an extensive pre-qualified preliminary plant list. One of its primary goals is to create a neighborhood community landscape that is self-sustaining and habitat supporting. And so the preliminary plant list contains mostly native and drought-tolerant plants. The plants are categorized by landscape typology: evergreen, deciduous, ecotone, and grasslands, and by plant type: tree, shrub, subshrub, grass, also by water use category, and several other factors. This list is the first stop on the way to a more detailed individual plant list for a particular project within the community. Detailed lists with specific purposes, such as habitat for endangered species, are put together from this one. As projects are designed and installed and the plants begin to grow, the list is adjusted as the plant's use and suitability in the community is evaluated over time. Whether there is a pre-qualified preliminary plant list by another landscape architect or not, we must make our own plant list. Plant research is educational and fun. Looking up plants, reading about them from multiple sources, finding and watching them during walks and drives, taking and gathering photos, putting them in folders or printing them out and pinning to a board helps solidify in our minds their images, forms, textures, and colors, especially when purposefully encountered repeatedly over time. The lists we just saw used a variety of software programs, but I suggest that Word is the fastest, easiest way to list and organize plants, and revise the list quickly and repeatedly. Once the Word doc is done, it is very easy to convert it to whatever other software you want to use. But if you have to make a lot of changes over and over in a more cumbersome program, you can waste a lot of time. The minimum plant notes that should be with each plant are a symbol notation, if applicable, and I like to use the 3-letter genus and species method, botanical and common names, height and width, sun and shade preference, water use category, usually that's wool coals, other notable characteristics like a flower color or some sort of special shape and form, and also make sure the USDA and or the sunset climate zone for the site is noted predominantly at the top of the list. In this example, from a residential community with a common area and a rec center, what the heck? That was weird. In this example from a residential community with a common area and a rec center, the left side shows portions of the preliminary plant list with only 2 groups of plants. Trees, and then shrubs and ground covers. The right side shows a later iteration with the plants categorized by appropriate location on a plan. The trees are grouped with entry, rec center, pool area, or yards, and the shrubs are categorized by potential use in foreground, middle ground, and background planting design locations. Refinement of the plant list occurs continually. Note that, on the left, a plant that has been deleted because it does not meet the climate zone of the site. And on the right, the notes for each plant are updated and amended. Note that the spacing has been added. And it's likely that other notes will be revised, added, or deleted as new information is discovered. All this is quick and easy to revise in Word, and not so easy in some other software programs. In the previous example, locational terms such as foreground, middle ground, and background are used for the plant list categories. Because that was a list for a residential community with blocks and mixed border planting design models, as shown in the first 2 images above. But remember, we noted that there are several other planting design models that we can consider to support the project's overall landscape approach, and they have alternate functional locational terms. And as we also talked about last time, the terms communicate where the designer thinks the plants go best. The categorized plant list is where the terms connect the appropriate planting model to the landscape concept. One of the most important locational considerations for plants is sun and shade preference. Next, we will take a look at sun and shade and how to make a simple graphic tool to evaluate it on a plan graphic. Suncalc.org is a free website that calculates sun angle and azimuth for any location at any time of year. The sun angle is higher in the summer and lower in the winter, and in the middle, twice a year during the equinoxes. Sun's rays are parallel, so a ray hitting the origin point on the ground is at the same angle as a parallel ray passing through any point directly above the origin point. The projection of a ray from a point above the origin point to the ground results in a shadow length for an object of that height. Azimuth is the direction from which the sun rays come. It is measured on a compass circle from 0 to 360 degrees with north at the top. You can use SunCalc to determine the shadow direction and length for any height object, such as a building or a complex of buildings. You can obviously use SunCalc to show you shadows for today, right now, but I suggest it will be more useful to average out typical days and times of day in order to give a sense of the cyclical changing of sun and shade during the year. So that way you can use the tool more educationally to enhance your sensitivity to the natural cycle. In Bluebeam, you can take SunCalc information and create a portable graphic tool to plot shadows on a site plan PDF. Because the sun angle and shadow lengths continually change throughout the day, this tool is designed to show shadow points for a benchmark time of year and 3 benchmark times of day. I have chosen the spring or fall equinox in March or September because the sun angles are neither at their highest or lowest points, and the angle azimuths are neither at their widest nor narrowest dimensions. I have chosen 3 times of day, mid-morning, midday, or the sun's highest point, and mid-afternoon as the benchmark times. So 9 a.m., noon, or 1 o'clock if it's daylight savings time, and 3 p.m. Let's start with suncalc.org. In the white windows in the upper left of the screen, type in your site address. Select a date and either type in the time of day or move the orange indicator button left or right. In the small white window labeled at an object level, type in the number 1. The shadow length can be read above this window. You can see it says 2.16. This is very important. With the object height set at 1, the shadow length will be shown as a multiplier for whatever object height you want to use. Play around with the dates and times, locations, moving the diagram, and the animations. Take note of the sun angle diagram over the site map and the compass circle and its cardinal points at north, south, east, and west. Note that this map is a top view of a sun's rays direction toward the origin point on the map. Now let's gather data on SunCalc and use it to construct our simple tool in Bluebeam. Type in 9 a.m. March 19th, 2020. Make sure the object level is set at 1. The shadow length should read 2.16, which it does. This will work out to 2.16 times the object height we choose to use. Save this image as a JPEG. Next, change the time to 1 p.m. and save the new screen image as a JPEG. The azimuth should read 179 point something degrees. Here it reads 179.82 degrees, which is almost due south. And the shadow length should be 0.67, so a little more than half of a height. Remember that on March 19th we are in daylight savings time, which means that the sun angle reaches its culmination at around 1 p.m. instead of noontime. It really doesn't matter much to factor in daylight savings times for our purposes, but I like to have a sense of the sun's highest point in order to take advantage of knowing what the shadows are at their shortest. So now change the time to 3 p.m. and save the new image as a JPEG. So here you have 226.65 degrees and the shadow length should read 0.97. So you have 9 a.m., 1 p.m., and 3 p.m. as saved screenshots. You'll use these later to transfer the azimuth angles for the 3 times of day to a Bluebeam diagram. Now, on Bluebeam, have a new file, a blank page in landscape format. Draw a compass crosshair with perpendicular lines and an origin point in the center. Label north 0 and 360 degrees, east 90 degrees, south 180 degrees, and west 270 degrees. The crossing point, or origin, on your diagram corresponds to the origin point on the suncalc.org screen map. Bring in the first saved screenshot, 9 a.m., into your Bluebeam space using the picture command. Draw a guideline over the east-west compass line on the screen image map and another through the north-south compass line, making sure they pass through the origin point on the SunCalc map. Those are the ones that are in red. Using a new color with an arrow at the end, draw another line from the little orange sun symbol on the SunCalc map through the origin point and continue it on for a good length. See, that's the little green line with the arrow that I have already put on the SunCalc map. Copy the line with the arrow from the SunCalc images and then paste it on the origin point of the Bluebeam compass crosshair that you just drew. There it is with its angle. Adjust the lengths of the line as needed, taking care not to change the angle that you have transferred. Just make sure it's long enough so that you'll be using it later, but not too long it's going off the page. Repeat this process using the 1 p.m. screenshot image, and then the 3 p.m. screenshot image. So you've brought that information from the SunCalc diagram into the Bluebeam diagram. So your Bluebeam diagram should now have 3 sun azimuth lines as shown with green arrows, just like this. Oh, there's the last angle. Note that when your sun ray passes the origin point in plan view, it has passed over a corner of an object located there, such as a building corner. The line now becomes a shadow ray that will continue until it hits the ground. You determine where it hits the ground when you assign an object height and multiply that height by the shadow length multiplier. There it is. Next, you will refer to the shadow length information in the 3 screenshots. Decide on your object height. Here I decided to use 30 feet. It's a good height for a 3-story residential building, more or less. Go to your SunCalc images and note the 9 AM shadow length is 2.16 times the object height. So the H is the object height. So H is 30 feet, so 2.16 H equals 2.16 times 30 equals 64.8 feet. Draw a line 64.8 feet long along the 9 AM line from the sun through the from the origin. To do this in Bluebeam, use the Measure Calibrate tool to set the page at a scale. For example, 1 to 20 feet. 1 inch equals 20 feet. And use the Measure and Length tool to make a dimension. You can increase the precision by selecting the dimension numbers and typing in the precise length. So you make a dimension, type in 64.8, click, press return, and you'll have a dimension. And then draw a nice black line with a dot at the end. And you'll draw that right up against your dimension lines. And then you can adjust the line length to match the dimension line. Label the 9 AM line with the shadow length equation, 2.16H equals 64.8. Do the same for the 1 PM and then the 3 PM shadow length lines. Label them with their measurements. Make these new measured shadow length lines dark and bold and mark the ends with a dot. Labeling the shadow length lines with their equations will help with scaling to a plan later, since no matter what the scale or what the object height, the ratios, angles, and proportions will be the same. So now select only the important lines that you need for the tool. That would be the north arrow, the east-west compass line, the 3 shadow rays and their labels, and the origin point. Once you've selected all those, group them all into one object. Grouping allows the proportional sizing of the object to another scale. This diagram, now a grouped Bluebeam object that you can copy and paste, will be your portable Bluebeam Sun Angle tool. You should have a diagram that looks something like this. The 3 shadow length lines at the appropriate sun azimuth angles for the 3 benchmark times of day. To use it on a PDF of a site plan, you need to bring in the grouped object, mask the background of the group object, and scale it to the site plan. So this site plan happens to be 1 inch equals 10 feet. North points straight up. The buildings are 3-story residential townhomes. So 30 feet for our object height should be about right. To bring your grouped object into your new site plan, use the copy and paste command. Now we need to make it transparent and therefore usable. So select the object, set the word fill to 0. You have objects and you have fill or no fill or different color fills. Set fill to 0. That's no fill. Then right over to the right you'll see mask. Set mask to white. And then there'll be the word tolerance to the right of that. Set the word tolerance to the number 8 or higher. The tool should now look transparent. As a grouped object, you can move it around on your Bluebeam site plan. But now you have to scale the tool. Remember, we created it in a 1 inch equals 20 foot environment. We need to scale it to a 1 inch equals 10 foot, which is the scale of the site plan. So, check the scale of your site plan first just to make sure it's right. So you go to Tools, Measure, and Length. And you take the measurements of a few typically known objects like parking spaces, doorways. You can see I got a few parking spaces, a couple of doorways, to see if steps are good too, to see if they make sense. If everything seems to make sense, proceed to scale the tool. So to scale the tool, it's a grouped object, remember. Use the Bluebeam Measure Length command to take a measure of one of the shadow length lines. Okay, so that will be a different number than what you expect. See the red line where it says 64.9½? It'll be different when you first measure your tool. So then you click on those numbers and type in what's on your tool. It says 64.8. Type that into the new dimension line that you just made, and then press return, and you'll end up with 64 feet and 9½ inches, which is the equivalent of 64.8. So now you click on a corner of your grouped object and drag it so that the entire object size changes, and keep lining it up with your dimension until it matches. This will take a little trial and error to adjust. You'll have to move it around back and forth, and you'll have to make it bigger or smaller until it matches. This one here pretty much matches, as you can see. So I tested it with 2.16H, which is the 9 a.m. line, and I tested it with the 0.97H, which is the 3 p.m. line, with two separate dimension lines to make sure it was right. Once this is done, the tool is ready to use. Now we can start constructing shadows for this 30-foot high building complex. Move the origin point of the tool to a building corner. Make a mark on the plan at the end of the shadow length line for 9 a.m. Move the origin to another corner and make a mark at the shadow length line for that corner, and repeat this for all building corners. Then you go to the polygon command and you make a translucent polygon, probably 50% or less solidity, so at least have it be very, very visible. You can see through it. So 50%, 40% solidity would be good. And then do this for all the 9 a.m. shadows that you have. For if you have two buildings, you have two 9 a.m. shadows. So make all the 9 a.m. shadows the same color. And I made this a reddish color. Now go to the 1 p.m. shadows and use a different polygon color. This color is a bluish violet. And by the way, so to avoid being confused, move your 9 a.m. shadows off the page so that you have a clear space to do your 1 p.m. shadows. This color is a bluish violet, so that'll be very interesting to see what happens when you overlap red and blue. Now repeat the same thing. Move your 1 p.m. shadows off the page, and then bring in construct your 3 p.m. shadows. Here I used a brighter blue color. When the reddish translucent colors overlap the bluish translucent colors, the overlap areas will be nice dark violet. You'll be able to see the overlap areas very clearly. So, in your Bluebeam space, you can now move your shadow polygons in and out of the frame at will. You can look at more than one time of the day at once and see how the shadows overlap. And with all the shadows viewed together like this, you can see which areas are in shade some, most, or all of the time. Look at the areas on this plan where all the shadows overlap. These are the areas that are in shade virtually all day long. Keeping in mind that this is a March or September equinox time of year, this is a mid-season snapshot of sun-shade conditions. Shadows will, in general, get longer heading toward the winter solstice and shorter heading toward the summer solstice. If you are interested, I will send you a Bluebeam file with the pre-constructed sun angle tool that you can bring into another site plan in PDF, and all you need to do is scale it to your plan. It will already be transparent, so you will not need to go through that process. Because in SunCalc we set the object height to 1, if you want to use a different building height, all you need to do is multiply your new building height by the same shadow length multipliers. Good luck, and have fun with sun and shade study.